So this unit is going to talk to us about how to do transformations on a graph. Okay, so we just are going to call any normal function just y equals f of x. And then we're going to input transformations onto any function. And you have done some of this in grade 11 when we graphed quadratics. Right? Remember us moving parabolas? We could move them up or down. We could flip them. We could narrow them, widen them. We did kind of that stuff. Okay, so here we go. A. What if I put something into this A position? So the A position is in front of the function. You multiply the f of x. Does everybody know that f of x is a fancy way to say the y part of a coordinate? Okay, so for example, if I just am normal on a graph y equals f of x, it's the input is x and the output is f of x. Okay, the input is the x part and the output is the f of x. So f of x is the fancy y part. You should. Okay, so this A multiplier, I'll just have to give you mine after I photocopy your dinner.
What are you all pushing me to do?
Okay, so the A is the multiplier. So if it's multiplying f of x, it's going to change the y. Okay, so every coordinate would become x comma A times y. I'm multiplying the y. Okay, so for instance, this coordinate is 0, 0. If I multiply the y by 2, I double the y. What happens to the 0, 0 coordinate? Nothing. Okay, then this coordinate is 1, 1. Where should I put it now, though? 1, 2. This coordinate is 2, 4. Where would it go? 2, 8. Okay. The word for this was called a vertical stretch. The word for that was called a vertical stretch. If A is bigger than 1, it stretches it. If you multiply by something more than 1, you stretch it. And vertical, because y, I'm changing the y coordinate. So that's vertical. Okay, so this, now there's a half. So x comma, now I'm going to just do a half times the y. Okay, so what happens to 0, 0? It stays again, because if I multiply 0 by, it doesn't even matter, right? It stays. 1, 1 will now go to 1, a half. And this coordinate was at 2, 4. So instead of a height of 4, it's going to have a height of 2. So again, here's what I did. The 2, 4 is now 2, 2, because a half of 4. All right, so this, I'm going to tell you that my A value now was less than 1, right? It was a half, so it was a less than 1 value. So if you multiply a y by something kind of a fraction or a decimal, it's going to be a vertical compression. So you're going to have to know the math, you're going to have to know the names. All right, so the next one, now there's a -1 in front. So x comma negative y. I'm multiplying by -1. So 0, 0, again, it's going to stay put. And 1 comma 1 is going to become 1 comma -1. 2 comma 4 is going to become 2 comma -4. So if A is negative, what's going to be happening in a word? You can call it a couple things. I'm going to go a vertical reflection would be one option. Celestine, I'm going to give you my paper after. And, or you can say this, reflect over, what did I reflect over top of? The x-axis. Does that make sense visually? You flipped over that x-axis. All right, so now the next is the b. So the b is now a multiplier of the x. Not the f of x, it's the multiplier in front of the x. Okay, so here's something silly. It's actually going to divide. It's going to do something opposite of what we think. Okay? You did this last year with quadratics, not the b, but you moved opposite left and right. So what does this look like? X divided by 2. If b is 2, I'm going to take the x value and divide it by 2. All right, so guess what happens to 0, 0? Nothing. It doesn't matter what I'm doing with multiplying or dividing. Okay, let's do a change to 1 comma 1. What is that going to look like now? Instead of 1, it's going to be a half, comma 1. And then what's going to go on with 2 comma 4? What's 2 divided by 2? 1. Do you guys know what the instrument an accordion looks like? Like this? When you're pushing an accordion, that's what I'm doing to the points. I'm like pushing them in to the x-axis. Does that make sense visually? Okay, so if b is bigger than 1, so this was 2, so I'm bigger than 1, it's going to be, do you know what the opposite of vertical is? It's going to be a horizontal, and I actually compressed. This is weird because your brain has to go opposite on you, because this is a big number, but you actually compress. Here we had the big number and we stretched it. So here a big number is compressing. It's going to go opposite. All right, so let's check this out. What if b was a half? So x divided by a half. Does anybody know what the exact same thing of dividing by a half is? If you multiplying by 2. Because you divide by a half, what do? You have to flip multiply. So divide by a half changes to multiply by flip 2. Okay, so 0, 0 stays. 1 comma 1 is now going to become 2 comma 1. And 2 comma 4 is going to become 4 comma 4. So we're going to say, if b is less than 1, so if b is some kind of fraction or some kind of decimal under 1, then we are actually going to horizontally stretch it. So it, like an accordion, pulls out now. Accordion, push the accordion in or out. Okay, opposite brain. Small number actually stretches. Okay, and then -1. So what happens if I divide by -1? It really just negates something, right? Dividing by -1 just negates something. So 0, 0 ended up staying. 1 comma 1 is now going to become -1 comma 1. Two comma 4 is going to become -2 comma 4. Okay, so conclusion, if b is negative, we are going to, and you can say this in 2 ways, I don't care which way you write. So you could say it horizontally reflects, or you could tell me it reflects over the y-axis. If you change x, you're flipping over a y-axis. All right, now we're going to move on to the C. So the C is with the x part. So you did this with quadratics, by the way, when you graphed a quadratic equation last year. This was your quadratic equation stuff last year. Where was the vertex? Do you remember how you did the vertex? +5, +3. It moved right 5, up 3. Okay, that's what you did in grade 11. Okay, so this is going to look like this. X minus C. You're going to minus C. Okay, what happens if you minus a -1? What happens if you minus a -1? You actually just add 1 then. So every x coordinate has to add 1. So 0, 0 becomes 1, 0. 1, 1 becomes 2, 1. 2, 4 becomes 3, 4. Okay, so if C is a negative value, if C is a subtract number, you are actually going to move to the right. Can I tell you the official name I'm okay if you just say right. It horizontal translation. It's a horizontal, no, I want to use the word shift actually. Or translation, a horizontal shift. Horizontal translation or horizontal shift, those are their fancy terms. And where does it shift? It shifts right. Okay, so here, what happens if you minus a positive 2? If you minus a positive 2, then we are just minusing a 2. Okay, so 0, 0 is going to become negative 2, 0. 1, 1 is going to become negative 1, comma 1. 2, comma 4 is going to be 0, comma 4. So if C is positive, what happens if you're positive? You're actually going to move left. Horizontal shift left. Horizontal shift or translation to the left. Okay, last one. So this one is a D value. So on the top here you can see the D was the end number. So what happens to D? Y plus D. It's a change on the f of x. So on this example, it's going to go y plus 2. So I'm going to do this one quickly because this is something you should be familiar with. You're just adding y's, so you're shifting stuff up, right, if you're adding y. So move it up, move it up. Okay, so the conclusion, if D is a plus, then we are going to do a vertical translation or shift. So we're going to be doing a vertical shift. If D is plus, we're going to go up. So this one, D is subtract 1. So there's my y subtract 1. So conclusion already, what's going to happen is that we're going to be doing a vertical shift down. So you're going to take your graph and you're going to just one down. So you can see what I did. I had those points and I just went down one with them. All right, so recap of the whole shebang here. All right, so let's go to the middle section here. A and D, the multiplier in the front and the adder at the end, affect your y. And when things do something to y, they happen in the same way that you see them. So if this is a multiplier, it's making something bigger. If this is an adder, it's adding. It's moving up. The B and the C affect the x values, and they do so in the opposite way that your brain wants to see it. So if you see a multiplier, it is actually a divider. If you see an add, it's actually moving left. Got it straight? AD affect Y, same as your brain wants to do it. B and C, X, but in your opposite brain mode. Okay, so these are all the things that we wrote. So A and D change Y, so anything with that should be vertical stuff. So we talked about big, vertical stretch, small, vertical compress, and then we talked about negative, reflex it. Vertical translation, you're either moving up or down. B and C change your X, so horizontal. So look at this. If B is bigger than 1, the big numbers compress. That's opposite. See here? If it's a plus, it's actually moving left. Opposite. All right, this box is the box that you need to make sure that you have memorized. How do you make a coordinate with all of those things involved? We divided by the B and we subtracted the C. So what did I do there? You can see that I have a B multiplier, but remember it's supposed to be opposite. So now it's dividing. This is a plus C, so I'm actually doing a minus C. And then what do you do to the Y's? You can multiply by A, and you can add D. And that's the same thing I see up there. I see the multiplier A and the adder on D. Okay, do you see what I'm doing? All that stuff to X is opposite of what I want to do, and the stuff to Y is the same. Okay, bed mass is involved. Order matters. So bed mass, if you have a multiplier, you got to do it before some kind of adder. So in words, you'd have to do a compression or a stretch or reflection before a shift, up, down, or something like that. Okay? Does that make sense? Bed mass? So you could see here, I would have done a multiplier. So this is a vertical stretch. I would have had to do it first. And then I would have shifted it up to after. All right, so let's pick out some of these names. All right, can you identify these numbers in here as A, B, C, or D? So I'll do the first one. I'm going to put a 4 as an A value, and then this plus 3 is a D value. You see how those line up with that original? So I'm going to write, there's a vertical stretch by 4. Just for time's sake, I'm okay, just these abbreviations, but on a test you're writing the full thing, right? Vertical stretch by 4, and then we're going to shift up 3. All right, so what do you think about the next one? What is the 4 letter? A, B, C, D. It's in the B position. And this is in a C position. Everyone's got that? Should I write it here one more time? Okay, this is it, always that. All right, so B is, it's affecting the X, so we should do opposite stuff. So I see a multiply by 4, so I got to think about dividing something by 4. So that is a horizontal compression. Opposite. You see multiply by 4, but you actually compress it. Anything with X, B and C, opposite. So you see a -2, so we're actually going to shift, opposite brain mode, right. Everything is X. So horizontal stuff, left, right stuff. Okay, the third one. That's an A. This is a C. Okay, so we are timesing by 1/5. This is a little tricky. What happens to some kind of number if you times it by 1/5? I'm going to write vertical because it's an A value. Can you think about timesing something by 1/5? What is it going to do to that number? So just take any number, 100. What's 100 times 1/5? 20. So what happened going from 100 to a 20? You actually compressed it by 5. Because your multiplier is a small number. So if we're small, we actually compress. This is a C. That's X stuff. So are we moving left or right? Did you pick left? Because you have to think opposite. All right, this is an A. This is a B. And what is that, a C or a D? It's a D. Why is it a D? Because it's outside of anything brackets. It's not in a bracket. Okay, so the 2, that's an A. So we're going to write vertical. What happens when you multiply vertical by 2? It's going to be stretched. Vertical stretched by 2. The 3 is a B. So I'm already going to write the word horizontal. What happens physically if you remember it's not a timeser, it actually divides by 3. So it's a horizontal compression. And then D is a vertical. So we're going to be moving vertically. How so? Down. Down 8. Okay, I'm going to give you a red flag on here. It's a test red flagger. There's a 100% chance this would be on a test. This question is not possible right now. Okay, so let's talk about why. What's going on with the original format I always have to follow? Do you see this here? It always has to be factored out. It always has to be in that format. Okay, so we have a problem. Do you see it now? It's not the right format. Y equals f of, can you rewrite it? 3 out, factored out. So then this would be 3 times x. And then subtract 2. So I changed it. Now it's good. All right, so then we can answer this is a B and this is a C. Okay, so 6 has nothing to do with my C because it wasn't the format I wanted. Okay, so I'm going to do a horizontal compression by 3. Horizontal compress by 3. And this is going to move something to the, did you pick right? Okay, did you all red flag that and put this is on the test? Somewhere I'm going to trick you about that factored out thing. So actually I think I put it on a test twice. All right, last one. We have an A, we have a B, and we have a D. Do you recognize those values? Starting to say, oh yeah, that's for sure the D position. Okay, so the A, negative. There's a reflection. What do you guys like to write? Do you want to write reflects over a certain axis? How does it reflect? If you change, you're changing Y. You're negating Y. So that's a reflection over the x-axis. Okay. B is 1/3. So you have to do opposite brain mode. 1/3 is a small number. So opposite brain makes it horizontally stretch by 3. Because math says dividing by 1/3 tells me I should times something by 3. Dividing by 1/3 actually changes that to a times by 3. And the last one is up to.